Alright, this is the general finding all the area under any curve using limits. And to find the exact area, we would need to add the areas of an infinite number of rectangles. This summation can happen if the width of each rectangle, what I call delta x, approaches 0. Either the lower bound, or the upper bound, may be applied. And if you think about it, they're getting smaller and smaller and smaller, so that area, if it's an under approximation or if it's an over approximation, will be minimized, so it doesn't matter if you use left corner or right corner. In general, f has to be continuous and non-negative on a closed interval a to b. The areas of the region are bounded by the graphs of f, the x-axis, and the vertical lines of x equals a and x equals b. So if you noticed on one of them I had a little vertical line because the graph did not hit the x-axis, so I run a vertical line to connect to the graph. And I think it was on the very first example I have. So what you're going to do is you can take the limit as n goes to infinity, and n is the number of rectangles, so it's going to infinity. And it's going to be the summation because you're going to add up all the areas, and the areas are computed as f of c sub I delta x, where delta x is, and it's kind of hard to see, so I'll see if I can fix this a little bit. This is an n. So delta x is b minus a over n, where c sub I is equal a, which is my first number, plus delta x times I. So let's take a look at this. It says find the area of the exact curve of f of x equals x cubed. And if I graph that, it kind of looks like this. Here's 1. Here's 1. Now notice this doesn't touch the x-axis here, so I run a vertical line in it, and I'm figuring out this area in here. Okay, so here's 0. So a is 0, b is 0, and the first thing I do is I figure out my delta x. My delta, oops, b is not 0. Sorry, b is 1. I'm getting too far ahead of myself. So I have 1 minus 0 divided by n. So I'm going to have 1 over n. C sub I is going to be computed as a, which is 0, plus delta x, which is 1 over n, times I. So C sub I, right, my counter on the bottom, that when I put it into my function gives me different heights, is going to be I over n. Alright, so now it says determine, you'll have left points or right endpoints. I always use right. This will help you find the heights. Write a limit statement involving the summation. So here's my limit statement. I'm going to round up here. I'm going to have the limit as n goes to infinity. And I'm adding up a whole bunch of rectangles. How many am I adding up? N of them, an infinite number of them. My function is x cubed, so I'm going to have inside here c sub I cubed, which is I over n cubed, times my delta x, which is 1 over n. So now I get the limit as n goes to infinity. The summation of I equals 1 to n. Well, if I cube this, I'll have I cubed over n cubed times 1 over n. And that's going to give me the limit. I'm going to rewrite this a little bit. 1 over n to the fourth times the summation of I equals 1 to n of I of the third. So you got to go to your notes. What's I of the third? So I'm going to take the limit as n approaches infinity of 1 over n of the fourth, and it is n squared times n plus 1 squared over 4. And that gives me the limit as n approaches infinity of n plus 1, that quantity, squared over 4n squared. So I'm going to take the limit as n approaches infinity. I'm going to multiply that out, and I get n squared plus 2n plus 1 over 4n squared. My leading coefficient is 1. My degrees are the same, so my limit is equal to 1/4. So the area underneath this this curve is 1/4.